Thanks, Nick. Good evening, everyone. My name is Jane Jabir. Unfortunately, I can't be with you in person tonight, but I hope you enjoy our presentation. Myself, Nick, Michael, and Rob are here to talk to you today about Sydney Football Stadium and the challenges we overcame during its design and construction. We'll be talking through the following topics: the project overview and architectural vision, substructure, superstructure, and bowl, the roof, and the construction phase. I'm sure most of you are familiar with the project. However, to put some context around today's topic, I'll firstly give you a brief overview of the stadium before the rest of the team take you through the finer details. Just a bit of background on myself. I'm a senior structural engineer at Aurecon and have worked here for the past 8 years. During my time at Aurecon, I've had the opportunity to work on some fantastic projects around the world. In 2018 and 2019, I worked on the superstructure package of the iconic flagship stadium for the FIFA World Cup in Doha, due to take place later on this year. Ever since that project, I've had a passion for designing stadia. It's the joy that the structure brings to so many people and the real teamwork approach during design and construction that makes the experience unforgettable. It was therefore such an honor to work on this team on Sydney Football Stadium and has been the highlight of my career to date. I worked alongside Nick on the superstructure package on all the vertical elements and the lateral retaining system. Sydney Football Stadium is a world-class stadium located next to the Sydney Cricket Ground in Moore Park. The redevelopment of the stadium is to ensure Sydney has a sporting and entertainment precinct of an international standard, and that New South Wales remains the #1 choice for sporting and entertainment events. Just a bit of a project overview and some stats on the project. Aurecon undertook the role of structural engineering consultant, with Cox Architecture as the architect, John Holland as the contractor and our client, and Infrastructure New South Wales as the overall client. The stadium has a massive total floor area of 110,000 square meters, all of which were different. Every floor was completely different, which is, to put that in perspective, is roughly the equivalent of 2 50-story buildings. The stadium capital cost is approximately $830 million and can seat 42,500 spectators. The key challenge and the ultimate success story of this project was the incredibly short 2.5-year design and construction program, with the planned completion to be around the NRL final series this year. This was always the key concern for John Holland and New South Wales, and therefore this was ultimately the key driving factor of how we needed to design the structure to align to the program. To make this dream project become a reality in the time frame required, we needed to allow the program to influence our design. We couldn't have a conventionally designed and then constructed project. We needed to be nimble in our design approach to allow for the best possible outcome with all the stakeholders involved, from shop detailers to procurement and fabricators. To achieve this, total collaboration and mutual trust was required between all of the teams. The past 2 years, minus a couple of months for a lockdown, was spent with the whole design and construction team in the project office. Firstly, in an off-site project office in the WeWork in Piermont, and subsequently on site. The couple of months spent in the WeWork with bottomless lolly jars and team get-togethers over drinks on Fridays were the building blocks for the confidence and trust we had earned in each other during the course of the project. The collaborative workspace on site enabled us to work efficiently and reduce delays due to mountains of correspondence over email or WakeNex, and by catching and resolving problems early. Although there were more than a few late nights and early mornings, the challenging atmosphere created a sense of team camaraderie, and we have formed many great relationships throughout this experience. This total collaboration from day one ultimately led to the success of this project. Our role as structural engineers is to make the architectural vision become a reality by bringing ideas to life. Cox's vision of a lightweight parkland stadium was the starting point for the key feature of the stadium, the beautifully formed, structurally complex diagrid roof, which Michael will get into a bit later. Cox has a proud legacy in this space, being the designers of the original Allianz Stadium. They rose to the challenge of creating something that fits in, yet also stands out, while respecting the elegance of the original design. As quoted by Cox Architecture, more community value, more experience for teams and fans, and with better connection to surrounding parkland and amenity. It is something that is simultaneously sculptural and highly functional. It is lighter, kinder to the environment, and more self-sufficient as a structure than any other major stadium in Australia. This beautiful parkland area of Sydney has become the heartbeat of major sporting and entertainment events. Without impacting the natural surroundings, the stadium produces a maximum functionality. We work tirelessly together with the consultant teams to come up with inventive solutions to reduce the bulk and mass of the structure for the ultimate viewing experience. The stadium was broken down into separate design packages. From our experience, the best way to break up the packages is a way that aligns the building methodology and the procurement and construction process. Together with John Holland, we worked up a design process that worked with their procurement strategy. By separating the structure into 4 design packages, this allowed us to work on all 4 packages simultaneously to meet the procurement deadlines. The next few slides are to give you an overall picture of the stadium so that when you go through the stadium in more detail with my teammates, you'll have some context of the overall project. The substructure consists of approximately 700 piles ranging between 450 and 600 in diameter. The size range was driven by John Holland's preference of piling rigs to be used on site. Pile caps were only provided where necessary, for example at core locations or where multiple piles were needed for a column. The basement slab structure was designed to act as a diaphragm so that all the piles could be engaged in sharing the structure base shear. Robert will talk more about this in a bit later. A contiguous pile wall was used as an earth retaining system. The core walls are the lateral stability system for the superstructure. The cores were constructed with a mix of jump forms, core climbers, crane liftable boxes, and conventional shutter cores. This was carefully thought out to enable speed in construction. The columns are generally circular and were formed using Formatube. Again, an agreed approach with John Holland to increase speed in construction. They are generally ranged in size from 450 diameter to 900 diameter, with the perimeter columns inclined up to 15 degrees. The floors were generally designed as PT banded beam systems, using profiled metal deck sheeting as loss formwork to reduce the propping requirements. To date, there have been approximately 7,000 deliveries of concrete, with 6,000 tons of steel reinforcement within the slabs. The rakers in purple weigh approximately 2,000 tons on each of the 64 radial grids of the stadium. These are the supporting elements for the precast plats. The stadium is big enough for the bowl to have lower, middle, suite, and upper tiers, all of which designed to have a close game day experience. There are approximately 900 precast plats on the project, ranging from 2 to 23 tons. And finally, the roof. There are approximately 4,000 individual pieces that make up the complex roof structure. The roof weighs approximately 2,000 tons, and the total length of the structural steel connected end to end would be 19 kilometers. I will now pass you over to Rob, who will take you through the substructure package. Thank you.